Okay, let's look at exam 3B, problem number 10. Right? So we want to find the area of the region enclosed by these two curves. Right? So let's do that. Right, first thing we do is we need to find points of intersection. So we're going to set them equal to each other. Right? So you have x squared minus x plus 5. Right, is equal to x plus 5. Right, so 5 is on both sides, so subtracting 5 from both sides, we can cancel those. And then I'm going to just put x on the other side by subtracting x. Right, by subtracting, I'm going to go over here. Right, I'm going to subtract x. So we have x squared is already there. Right, then you have negative x, subtract this, so negative 2x. So that takes care of this guy, and this guy is gone. So this is going to be 0. All right, factor it out. So x is in common. X is factored out. So if you factor x from x squared, you got x left. X from negative 2x, so it's going to be negative 2 left. It's equal to 0. All right. So it's going to have a points of intersection at x equals 0 and x equals 2. Right? So those are the two values. All right, then let's sketch the picture so that we have a ballpark idea of what it's going to look like. And all we want to know is basically which is on top and which is on the bottom. All right, so let's see. So you have x-axis, right? And draw the y-axis, maybe around here. All right, then here's the origin, right? So let's do the easy one. So y equals x plus 5. So slope is 1 and y-intercept is 5. So it's going to be 1, 2, 3, 4, 5. Right? So right here, right? Then slope is 1. So it's going to look probably something like that. Right? So that's going to be 5 right there. Right? This is our G. Right? And then you have f is a parabola, and leading coefficient is positive, so it's facing up. And we're going to have intersection at x equals 0 and x equals 2. So here's our 2. So it's going to go up here. Right, that's going to be another intersection. But you have a parabola facing up, so I'm going to guess what it's going to look like. It's probably going to look like something like that. So it's going to look like something like that. Right? So that's our function f. All right, the region is going to be, looks like this is going to be the region that we want. Right? All right, so let's find the area A. Right, so it's a little, right, area A. So area A is going to be integral, right, from 0 to 2. So 0 to 2. Right, top one is x plus 5 minus, right, then parabola is x squared minus x plus 5 and dx. All right, let's evaluate. Oh, actually, we have to simplify it first before we find the antiderivative. From 0 to 2, all right, so you have a 5 minus 5, cancel out. So you have x minus negative x would be 2x, right? Then you have a minus x squared. So minus x squared dx, right? So find the antiderivative, which is going to be 2 times x squared over 2, and 2's cancel out. All right, minus, add 1 to the power, x cubed over 3, which goes from 0 to 2. All right, then we can just plug in 2. So you're going to get plug in 2, so it's going to be 2 squared is 4 minus, right, 2 cubed over 3 is 8 over 3, right, minus, plug in 0, 0 squared is 0, and 0 cubed over 3 is still 0, right, so that doesn't really matter. And let's see, this is going to be, right, 4 is 12 over 3 minus 8 over 3, so it's going to be 4 over 3, right? So that's the area of the enclosed region by the graph of these two guys, right? That's it. I hope that this was clear.